Hi guys, welcome back to the channel of today I'm doing a simulation of waves as my teacher asked me. Now let's go on. Here's the simulation. It's here as manually. Manually you can move it up and down. And here these guys has the loose end, fixed end and no end. I will show this now and manually oscillate and pulse. And we have slow motion, normal and normal speed. We have damping and tension, ruler, timer and reference. Whereas I'm measuring for the wavelength. Wavelength are the wait just a second. The wavelength is measured from one crest to another crest. Usually we're talking about transverse waves. Transverse waves have consist of one crest and a trough, which is these are highest point is called as the crest, which is this one, and the lowest point is as the trough. But manually it doesn't show very clearly. Let's go to oscillate. This point is the lowest point. And now let's see how about the frequency and amplitude. Amplitude is the measurement of the wave from its rest position. Now let's take out the ruler. This is measuring for the wavelength. Wavelength is measured from one point to another, such as from one crest to the next crest, or from one trough. Yes, from one trough to this trough. So let us see how much is the measurement. This is 4 centimeter of the wavelength, and this one the amplitude. Let us see. The amplitude here is 0.75. But let us check. Yep, 0.75. And let's get the amplitude to the higher. Taking more amplitude it makes up more higher waves. See, even more frequency, 1.50. It means 1.50 waves per second. Usual frequency is number of waves per second. Well, this is not a wait. That's so high. Okay, see, 3 waves. Now let's take out the rulers. Now, how about the wave period? Measuring the amount of time. Banderas in degree of 1.50. Above 0.75. Timer is usually for finding the wave period. Now let us start. Okay, we have to wait just a second. Okay. How many? Stop. The wave period is usually measures the time that it takes for these whole waves to finish. Well, usually it's 1.72 seconds. It's about, because I didn't see it well, it's 1.72 in this. It should be more than the frequency because these are measure of 2. So let's see. Let's get on with the loose end, no end and fixed end. Well, I'm going back to the manual. You can move it by yourself. Fixed end, usually it reflects the energy. As you see now, energy is reflected by the fixed end. More reflected. But in loose end, energy is reflected but not much more in the fixed end. Like see here, goes back. No energy is reflected, just open end. No end, sorry. And no energy is reflected, goes there, nothing comes back. Let's get on with damping. Damping usually is if you move like the wave, it's going to stop recently. Like see, stopped. This is about the damping. If you had non-damping, what you will expect to happen? Energy will flow every time. It won't stop. See? Energy will go back. It's so dizzy now. Go back and then go back. How about loose end? Loose end the same thing, but energy is much little bit more reflected. No end, bye bye, no more damping. Tension is about the slow motion or the normal, like as if now high tension it's going to go like in more time, like faster. If we did like low tension, what would I expect to happen? It's not like about the time, like it's more like picky, the crest and the trough, like more pointy, such as taking it like this or more tense goes more faster or like more comfortable. Like in oscillate, moving it, see it much more clearer than manually. Well, I expect to use more oscillate, goes up and down, but tension and low, it usually also affects like the frequency, not that much, because frequency it moves by how many waves? 1.50 now waves per 1 second, so it also depends on the time. Now let's get on to moving to pulse. Pulse is usually the wave of heart beating, goes up and down. Oh wait, I forgot the tense. Put it high. The heart beating, it doesn't have any it doesn't have any trough, so it's only crest. It goes up, then wait, let's just do fixed end. See, no energy is going to go back because of the damping. Go up, go down, go down, go on with the Z. Slow motions, it makes the waves goes much more slower. The amplitude is also the same thing. It makes it much more longer than its rest position. Goes up. And what about the width? Let's go. Width is also about like the measurement from, like, wait, width is like from this green point to there. This is the width that is happening on this wave. Pulse is only used for heart beating. That's the only that I know. Getting back to the original transverse, using it by the oscillate. Well, we are, as I said, fixed end reflects back energy because of the damping. Okay, now you can reflect much more. Loose end reflects less. No end, no energy is reflected. Well guys, what have you learned today? We learned that we learned about amplitude, frequency, damping of the waves, tension, the wavelength, which you use ruler, and amplitude. You also use a meter or centimeter. It usually uses the centimeter or meter for describing it. Now it's 1.25. Timer is for the wave period, measuring of all of these waves, how many it goes by the second. And how about go and manually, it just goes by your hand, moves up and down. Oscillate by itself. Pulse used for heart beating. So bye guys, hope you enjoyed the video. Don't forget to subscribe. This video is supervised by my teacher Muhammad Abu Ghanim. Bye guys, see you in the next video.